Ladies and gentlemen, adding polynomial fractions. Whenever you encounter a fraction that has polynomial expressions inside of their parts, you still need to remember the basic rules for adding and subtracting fractions, which is in order to actually perform this operation, you need a common denominator. The bottom part has to be the same. If it is the same, you keep that common denominator as part of your answer, and you perform the operation to the numerators. 5 plus 3x to the second power. Since these are not like terms, because of his x to the second, we just write them as said. 5 plus 3x to the second. No problem. The difficulty comes in whenever you do not have a common denominator. I have changed the plus 2 from this one into a minus 9. Otherwise, everything else is the same. But no longer are these denominators common. When this happens, you must make a new denominator that is the product of these two binomials. Product means to multiply. So, we mean this. The two denominators that are different have to multiply one another. Notice we haven't done any actually multiplying yet. We have not done any distributive or FOIL method. We're just showing that this is supposed to happen at some point. If you change the denominator to a common one, you must also change the numerators. And they change by multiplying, cross-multiplying, the polynomial at the bottom here and this one here. So 5 is supposed to multiply x minus 9. I'm not actually going to do that. I'm just going to show that it needs to be done. There is a plus symbol here dividing what we call the two groups. Group 1, when we cross multiplied here and got this, and group 2, when we cross multiply the other two. 3x squared times x plus 2. When you're separated into two groups, you're looking for something that may be common. If there's a binomial or specific number that might be common to both group 1 and group 2 on the left and right, but there isn't. So now we just need to go ahead and complete the process of multiplying the top and combining the like terms, and then multiplying the bottom to end up with our final answer. So if 5 multiplies what's in the parentheses behind him, we shall end up with 5x minus 45. Plus symbol, and now distribute again on the top with the second one that you encounter with. 3x squared times an x. That would give you 3x to the third power. Why third power? Because 2 and 1 make 3. Whenever you multiply, exponents add. 3x squared then multiplies the positive 2, and you will get a positive 6x squared. There are no like terms to combine. We've got an x to the third, x to the second, x to the first, no x at all. So now I'm just going to put it in standard form. That would lead off with the 3x to the third, because he's the highest degree, or exponent, followed by the 6x squared, and then the 5x, and then the minus 45. I have completed my numerator at this point. Now I need to work on the denominator. I'm going to do that over here. This is the FOIL method. So I need to distribute the x to the x and the negative 9. X times x is x squared. X times negative 9 is negative 9x. 2 multiplies through. 2 times x is positive 2x. 2 times negative 9 is negative 18. You end up with like terms in the middle. If you combine those, you end up with a final denominator of x squared minus 7x minus 18.